So hey guys, today I'm going to review a code. Problem statement of the code is implement a circular link list. So we just have to implement, link say circular link list. You can see that the problem statement have given the constraint on it is a double link list, double circular link list or single circular link list. So for the simplicity and without a loss of generality, I will be considered this as a singly circular link list and we will implement the code, and also the code is given in this format also. You can see the code. So this is the code and I'm going to review the code. So before reviewing the code, let me just give you some brief idea about what is singly linked list and how the code is written, and any shortcoming of those codes is not presently not. So okay. So what is the circular linked list? So we know that simple linked list is okay. So suppose that this is single linked list. You all know that this is single linked list, structure of single linked list. And a circular linked list means, and single linked list, at the end of linked list, the last element will contain a null value. So, and simply this is a simply linear linked list, okay, or the linked list. Okay, this is linked list. So, what is circular linked list now? Now the question arises: what is circular linked list? So what is circular linked list? So let me just show you guys what is it. So it is not any different from single linked list. So you will just come to notice this is 30, this is 40, this is 50, and the last element of this circular linked list point to first element means last element will contain the 10 element. So you can see this is a basically circular linked list. You can see the circle as informed, the circular linked list. So this is the basic idea of circular linked list. So what we have to do, we have just given a problem statement that design a circular linked list, implement a circular linked list. So we just create a node and implementation we means insertion. So we just need to know the insertion part only. So let me just explain that part, insertion from beginning and from end, and the code will be self-explanatory then. Okay, so let me just so now suppose we are just dealing with two conditions only, at beginning and at end. We can also design a third code like implementing in a in ith position. Okay, so now just explain the first code, that is insertion at beginning. So first of all, let me show you the approach how we're gonna insert the linked list in a beginning part. So means head will also have head pointer. So how we gonna insert this? How are we going to perform this operation? So suppose similar manner, new node will be created. So and it has to be inserted at the beginning. So what the tasks we have to do so that the data is not lost. Okay, data storage is important. So this is the new node. Okay, suppose something 200. So we have to insert at this node at the beginning. So what we have to do? So it's just one step more one from the simple link list. So what we have to do? We just have to make it point to this next, and the head will point to this, and this will become our first node. Means sorry, this is the point of this, no, not this. Okay, so what we have to do? We have to put new node in null, so we can perform anything. Okay, so suppose new node equal to head. So whatever head have value, it will put at the new node. So now it will have value of 10. Now it will point to this. Okay. Now the structure is not been yet destroyed. And one more thing we have to do. No, we cannot insert at the beginning without traversing this node. Earlier, in the case of singly linked, you can just, if you have to insert the node at the beginning, we did does not have to traverse to it. But because this is circular link list, so we have to know the last address so that we could make it point to this. This address has to point by this, so I have to traverse this. So suppose we traverse this part and we reach to this node, and suppose this node is denoted by T. Now what do you have to do? So we reached it, and one more thing we have to do, that before pointing it to head, just make it T of next. Means T of next equal to what? New node address. So it will now point to this, and it will have the value of 200, not 10 anymore. Okay, 200. Now one more step we have to do. We just have to make head equal to new node, because head now have to be point to this node. So this will be head. New node like this will be, this will the first element, this will second element, this is third element, fourth, fifth, sixth, similar manner. So this is the part of inserting a beginning. So hope you understand this, guys. Now let me explain you insertion at end. Okay. So what we have to do? So again we have to take the linked list. So just wait for. So this is our linked list. Okay. Now we have to perform the insertion at end. So firstly, one node have to create it. So this is the new node. So what we have to do? And it's have value something. We assume that it have value 15 null, and it will have some address like 10. So it have to insert it at the end. So what the steps needed to do this? Now, firstly, we have to traverse to the end. Okay, so traversing have to be done. Say traverse. So we have to traverse the node, and after traversing, we will list at the end. Okay. So now, what we have to do? First of all, we will have to make this point to this or not. First of all, we have to do it. So before doing, if you directly point it, and you will completely lost the circular list first address. So what we could do, we could just make, first of all, choose a null value and make it as head value, means new node equal to head, means will have, it will point, start pointing to, it will just point to head. Okay, first step is done. Now second step could be, what we could do, just make t of next, if the traversing variable is t. Okay, so t of next should be equal to new node. So t of next will point to new node. Now new node have address of 10, so it will point to this. So in this way, the list is created now. Okay, so these are the two steps involved: insertion at end and insertion at beginning, which I have shown you. That was an insertion from in beginning, and this was an insertion from end. So these are the two codes. Okay, so don't remember this code. Okay, because this code can be changed anytime. Okay, I am thinking about different logic in this case. Another time I will explain you. I will give you some another logic. Okay, so this one, that was a two case. Now let me just review the code and show you the print function. So this is the code, guys. You can see we are declaring class same. Then after that, we are just creating a linked list and insert first function inserting at the important thing is the null function. So what if there is no list? Then we have to just point, make node to head, and just make head point to node, means it's a self loop. Okay, so one node is present, it is pointing to itself. So if there is one node present, it will behave as self loop. Okay, so now this is the case for inserting in a beginning, or just traverse from the node and just use this logic. Okay, this is from the end. Okay, this is for the starting from the end. Okay, which I've shown you the logic. So there is no error in this code, perfectly fine. I like this code. And now the means beginning, from beginning part. Okay, this is from the beginning part. They have written so many steps, but you can do it two step also. Okay, I have designed my own code also in a two step. And one more part is, you have to remember this part. Okay, while t of next not equal to head, just print the value, print function, and one time also we have to print this value. Why? Because suppose there is one node, if there is one node, then it will point to itself, and then the data will never be pointed, because it's not equal to null, and it will come out of the loop. So for that part, this has to be done. So everything is written perfectly fine. So I can say that this is very good code. There is no, and one more thing is, you can include the delete function also, but it is self-sufficient. Okay, also the it is an infinite loop type, but there is break statement here, and this is also print value. Okay, so let me just run the code for you guys and show you the output. So what you have to do? Suppose you have to perform insert at start. Okay, so value, put the value. Okay, and then perform y again. You have to perform this. Then again insert at 1. Suppose the position is 12, 14. Okay, so 14 will be before 12. Then again put y, and again run the code as 1. Three element have to inserted at the beginning, 89 inserted at the beginning, and then again perform y, and now perform from end. Just print one element at the end. So list should be like 89, 14, 12, and if you insert a data at the end, what will be the result? Suppose we insert -1, so -1 should be at the end. Okay, so let me just print the value. So what could be the output here? The output will be actually, rule will be 89, then 14, then 12, and then -1. Oh, it's not working. Okay, let me just show you here. Okay, so it could be the case here. 3. So you can see that 89, 14, 12, and -1. So hope it is clear to you guys. Okay, so this code contain have no error, and it's self-sufficient code. And one more thing, additional field can be done. Like you can insert at any position, and just also include the delete functions. Okay, so here you can see the it give the same output. Okay, so that was the case, guys. So that was for this all this code. Okay, so hope you guys like my review. Okay, so thanks for watching. See you soon.